Okay, so now we're going to continue with special right triangles. And this time we're going to discuss 30, 60, 90 triangles. Okay? In 30, 60, 90 triangles, we can see what the relationship here is between the three sides of the triangle. If I could give you any advice, I would probably tell you to remember that the little leg is the boss. The little leg tells everybody else what to do. And the way that you find the little leg is that the little leg is always across from the smallest 30-degree angle. That's how you know that it's the little leg. And the little leg is the boss. It tells everyone what to do. How do you know the little leg tells everyone what to do? Well, take a look. Here, the little leg has a value of x. And the little leg is telling the hypotenuse, listen, you're always going to do double the work that I do. I don't feel like doing it. I'm on vacation, so you're going to do double the work that I do. So whatever x is, the hypotenuse is going to be 2 times x. Now the little leg tells the long leg, and by the way, how do you know it's the long leg? Because the long leg is always across from the 60-degree angle. Okay? And the little leg tells the long leg, you know what, listen, you're going to do the same amount of work that I do, except you're going to do it times the square root of 3. So the little leg tells the hypotenuse, I guess the little leg doesn't really like the hypotenuse that much, huh? He tells him, hey, you're going to do twice the amount of work that I do, and the little leg tells the long leg, you're going to do the same amount of work that I do times the square root of 3. So let's take a look at some examples here. So, for example, here I have a 30, 60, 90 triangle. I know that this is my little leg because it's across from the 30-degree angle. So if the little leg is 3, I know then that my hypotenuse is going to be 6. And then I know that the long leg is going to be the same as the little leg times the square root of 3. So this is going to be 3 times the square root of 3. Let's take a look at another example. Here I have, again, I have a 30, 60, 90 triangle. I know that this is the little leg, not because it looks so much like the little leg, but because it's across from the 30-degree angle. So I know that the little leg is 4. So then right away, I know that my hypotenuse is going to be 8. And then I know that the long leg is going to be the same as the little leg times the square root of 3. So the long leg is going to be 4 times the square root of 3. Let's take a look at another example. Here, I have a 30, 60, 90 triangle, and they have given me the hypotenuse. They have given me the hypotenuse. The hypotenuse is 10. Well, I know that the hypotenuse is twice as big as the little leg. So if this is 10, I know that the little leg is going to be 5. And if the little leg is 5, well, I know that the long leg, because I can see it here on my reference sheet, the long leg is the same as the short leg times the square root of 3. So the long leg is going to be 5 times the square root of 3. Let's take a look at another example. Here I have, again, a 30, 60, 90 triangle. And it's across from the 90, so I know they've given me the hypotenuse. I know that this 30 degrees here, so this is my little leg. Well, if my hypotenuse is 6, and I just change the orientation, you know what, let's change that number because it's too similar to another one. Let's make it 20. Let's change that from a 6 to a 20. So if my hypotenuse is 20, well then I know that my little leg is going to be 10, and then I know that the long leg is going to be 10 times the square root of 3. Let's take a look at another possibility. Here I have a 30, 60, 90 triangle. And so far, it corresponds, it looks exactly as the way that it should, right? I know that this is my long leg at 60 degrees, it's across from there, and the long leg is always equal to 2 times the square root of, the little leg times the square root of 3. So, if the long leg is 2 times the square root of 3, what's the little leg going to be? What's the little leg going to be? Well, if you guessed 2, you guessed correctly, and then that means that my hypotenuse is going to be 4. Let's take a look at another example. Again, here I have a 30, 60, 90 triangle. I know that this is the hypotenuse. I know that here's 30 degrees, so that's my little leg there. And I know that this is the long leg there, right? Well, the long leg, right, is across, they told me the long leg is across from the 60. Okay, I got that so far. And I know that it's x times the square root of 3. It's the little leg times the square root of 3. So if the long leg is 3 times the square root of 3, what do you think the little leg is going to be? Remember, the little leg is the boss. Little leg tells the long leg, you're the same as me times the square root of 3. So if the long leg is 3 times the square root of 3, the little leg is going to be 3, and the hypotenuse is going to be 6. Now, obviously, we all know that the questions in regards to special triangles are not always going to be this easy. We know that they're not always going to be this easy. There are going to be some gotcha questions. So let's take a look at what those gotcha questions might be, and let's see what shortcuts we can use to deal with them. Here's a good example. Here, I have a 30, 60, 90 triangle. I know this is going to be my hypotenuse. This is 30 degrees, so this is going to be my little leg here. And the long leg is across from the 60, just has the number 2. When I look at my picture here, I know that the long leg should be a number times the square root of 3. Because the little leg tells it, hey, you're going to be the same as me times the square root of 3. But when I look here, there is no square root of 3. Let me see. If my little leg was x, then my long leg would be x times the square root of 3. But I don't see a square root of 3 there. Why is that? Oh, I know why. Because they already multiplied it in there. The square root of 3 has already been multiplied in there, and the answer that they got when they multiplied it was 2. Which means then that I have to pull out a square root of 3 from the 2. I got to pull that out. And let me show you what the shortcut for that is. Anytime you pull out a square root of 3 from 2, it's going to be 2 times the square root of 3 divided by 3. Okay, I know it seems a little bit intimidating, but that's all you got to do. You're accustomed to seeing the square root of 3 here, right? It's not there because they already multiplied it in there, which means that for the little leg, you're going to have to pull it out. So when I pull it out, it's going to be 2 times the square root of 3 divided by 3. Let's take a look at another example just to get you comfortable with that, okay? Here I go again. I have a 30, 60, 90 triangle. The long leg has a 9 there. I should be seeing a square root of 3 next to it, but I don't. The reason why I don't see it is because they already multiplied it in there. So I got to pull out a square root of 3. So when I do that, I'm going to get 9 for the little leg times the square root of 3 divided by 3. It's going to be 9 times the square root of 3 divided by 3. Now, could I simplify this a little bit more? Sure, because what's 9 divided by 3? 9 divided by 3 is in fact 3. So my answer could also be written as 3 times the square root of 3. I could do 2 divided by 3, but that would give me a decimal, and I don't want to do that. So I just leave it like this here. Now you might be asking, Mr. C, why are you ignoring the hypotenuse? Because right now, I just wanted just to get comfortable when they give us a long leg that doesn't have the square root of 3 next to it, okay? We're going to discuss the hypotenuse very quickly. It'll take 2 seconds. Let's take a look at another example. Here again, there's an 11 and there's no square root of 3 next to it. So, what happened to that square root of 3? That means that they multiplied it in there already, so I have to pull it out. So when I do that, it's going to be 11 times the square root of 3 divided by 3 for the little leg. And that's all you got to do, guys. That's the shortcut. That's what it is right there. It's that simple. Now remember, this is the little leg, right? The little leg is the boss. The little leg tells everybody what to do. So you're wondering, if I have all of this stuff here, what's the hypotenuse going to be? It's very simple. Remember that the hypotenuse is twice as big as the little leg. So that means then that the hypotenuse is going to be 4 times the square root of 3 divided by 3. This hypotenuse here, well, depending what you want to say, if you wanted to do this without doing this, well, what's double of 9? It's going to be 18. So it's going to be 18 times the square root of 3 divided by 3. And of course, 18 divided by 3 is 6. So you're going to get 6 times the square root of 3, which would be the same thing you get if you double 3 times the square root of 3, just the number on the outside gets doubled. 3 times 2 is 6. 2 times 2 is 4. It's doubled. So naturally here, my hypotenuse is going to be double the little leg. 22 times the square root of 3 divided by 3. And that's the shortcut, guys. Let's take a look at another gotcha question. Okay? Again, if this went by a little bit too fast for you, you can pause the video, rewind it, and play it again. Let's take a look at another gotcha question. Here, they're telling me that my little leg is 2 times the square root of 3. Okay, interesting. But I know for a fact that the little leg is the boss. It's across from 30 degrees, that's the little leg. The little leg tells everybody what to do. So if the little leg is 2 times the square root of 3, the hypotenuse is going to be, the hypotenuse is going to be twice as big. So it's going to be 4 times the square root of 3. If here I have a little leg of 4 times the square root of 3, I know the hypotenuse is going to be twice as big, so it's going to be 8 times the square root of 3. Here I have another example where I have my little leg where it's 6 times the square root of 3. That means that my hypotenuse is going to be 12 times the square root of 3. And you're saying, Mr. C, why are you avoiding the long leg? I'm not avoiding it. I'm just taking care of the easiest one first, taking care of the hypotenuse. Now let's talk about the long leg. If we look here at our diagram, we know that the long leg comes from the little leg tells the long leg, hey, you're going to be the same as me, but you're going to get multiplied times what? Times the square root of 3. So here's my little leg, here's my long leg. Little leg is the boss. Little leg tells the long leg, hey, you're the same as me, but you get multiplied times the square root of 3. Well, if you're the same as me, then this is going to be 2 times the square root of 3. And that, my friends, is going to get multiplied times the square root of 3. Which is going to give me, well, let's take a look here. Square root of 3 times square root of 3 is going to be the square root of 9. So I'm going to have 2 times the square root of 9. I know that 9 is a perfect square, and that's going to be 3. So I'm going to get 2 times 3, and that's going to be equal to 6. So the long leg is going to be 6. Let's take a look over here. Again, the little leg is the boss. Little leg tells a long leg, hey, you're the same as me. There you are, you're the same as me, except you get multiplied by the square root of 3. So now I just, simplify. So the square root of 3 times the square root of 3 is the square root of 9. I know that the square root of 9 is a perfect square, so really I'm going to have 4 times 3, and 4 times 3 is equal to 12. So the long leg here is 12. And finally, here's another example. Again, here's my little leg, here's my long leg. The little leg tells the long leg, hey, you're the same as me, but you get multiplied times the square root of 3. So again, I'm going to simplify my expression by multiplying the square root of 3 times the square root of 3 gives me the square root of 9. I know that that's a perfect square, so that's 6 times 3. And 6 times 3 is 18. So the long leg is 18. And that, ladies and gentlemen, are the shortcuts for dealing with 30, 60,